Alrighty, we are ready for lesson 2.8, area of any regular polygon. We will talk about what a regular polygon means. It's just regular. It's not very cool. Our goals for today are to decompose regular polygons into triangles and to solve problems involving the perimeter and area of regular polygons. Some examples of regular polygons. So maybe we need to write down what this word regular means. Regular polygons, all sides are the same length. So that's what makes them so special. Some examples of regular polygons: we've got an equilateral triangle, a square, a regular pentagon, a regular hexagon, a regular heptagon, and a regular octagon. You guys have seen my struggles with drawing even a trapezoid, so when I start to sketch these out, feel free to giggle to yourself because it is not going to be pretty. I think it is important for you to note how many sides each one of these things has. So I'm going to go ahead and stop recording for a second and jot down how many sides and a little key for the regular polygons. After I put that back on, I would like for you to pause and do the same thing in your journal. So I have jotted my notes in. Go ahead and pause to write those things in. A couple of side notes here. Our prefixes in math and science, our Greek and Latin root prefixes and suffixes, can really help us figure out what in the world we're dealing with. There are connections there. So equilateral triangle, equa meaning equal, lateral kind of like lines. So equal line triangle, tri means three angles. So a triangle with all the sides the same. Square is just a square. We know they have four sides. I have it written here. Pentagon, that prefix penta means 5. Hexa means 6. Hepta means 8. Nope, 7. Sorry, I was looking ahead. Octa means 8, like an octopus has 8 legs. There are other ones. There's like a dodecagon. There are a lot of other funny names. A nonagon. So those are just some things that you could research on your own. Yes, we've got octagon with 8. A nonagon would be 9 sides. A decagon would be 10. I do believe a dodecagon is 12. They just have some fun names. So, regular polygons means their side lengths are the same. So to visualize regular polygons, so this right here is what you'll see in math, and this is just a connection that I have. So there's a game that's pretty old because I know that my dad played it back in the day for fun. It's called Trivial Pursuit. It's a trivia game. And it's kind of like, I think there's like a Disney trivia game that's like this, where you fill up Mickey's head and stuff as you get the questions from different categories correct. So the different colors mean a different category, and as you answer those trivia questions correct, you get a pie piece thing to put in your guy your goal is to get one of every color and fill up your pie thing with the trivia questions first. So what that reminds me of, all these little triangles, is finding the area of regular polygons, because these are like the little triangles that you put in there. Just a connection I have. I bring it up to maybe create a connection for you. So the formula for the area of any regular polygon. So we need to go back to the beginning of the chapter to our formulas page. So any regular polygon. Area of any regular polygon. So that could be any side numbers. We could figure out something with 100 sides. I'm definitely not drawing that for you. So our area would be base times height divided by 2 times n. N is your number of sides. So go ahead and pause to write that formula in. I wrote it out in words on this slide also to calculate the area of one triangle, essentially. That's where your base times height divided by 2 comes in, and then take it times the number of sides. So you find one of the Trivial Pursuit pie pieces and take it times the number of those pieces that there are, essentially is the process that you're doing. Back to our notes page, we're going to practice how many same size isosceles triangles are inside this pentagon. So we see our dashed height line right here. That does not break this into two triangles. These tiny, tiny dashes right here, that's a triangle. This is just our height of the triangle. So we've got 1, 2, 3, 4, 5 triangles. This is a pentagon and it has 5 sides. So the number of sides tells us how many triangles there are. The shape has a base of 4 centimeters and a height of 3. So I've got my base of 4 right here. I've got my base of 4 drawn in and my height of 3. So I've got my base of 4 and my height of 3. Hopefully you've labeled or you're aware of this somewhere, because this is going to disappear, I think, when I try to go to the next slide. So that's what it would look like, 4 and 3. So with that, I'm going to sketch in my first regular polygon. We're going to pretend that it's even and break it into our 5 triangles. We have this one that is base of 4, height of 3. So in order to calculate the area of this triangle, I'm going to plug into my triangle formula. 3 times 4 divided by 2 is 12 divided by 2, which gives me 6. So this one triangle has an area of 6. How many triangles are there? There are 5. So 6 times 5 gives me 30 square centimeters. I kind of worked ahead of our presentation there. Okay, looking at this is essentially what we just did. We're going to think about the number of sides, calculate the area of one triangle, and remember to multiply that by the number of sides. When you calculate the area of a triangle, remember you must divide by 2. So we did our 3 times 4 divided by 2, which gave us 12 for one triangle, or this one triangle. There were 5 of them, so we multiplied by 5. In this case, we've got 1, 2, 3, 4, 5, 6 sides now, so this is same dimensions, different shape. So do I really need to do a ton of recalculating? No. I know that one triangle is 6 square centimeters times 6, because this is the number of sides. 6 times 6 gives us 36 square centimeters for this shape. And I'm writing and you can't see again. There we go. So this 3 times 4 gives us 12 divided by 2 gave us 6 for one. There are 6 of them because there are 6 sides. So I get 36. We're going to do the perimeter and area, and if you were paying attention, I just gave you the perimeter answer. Looking here, I'm not going to redraw this shape right now. For the perimeter, one side is 12. We can count. There's 1, 2, 3, 4, 5, 6 sides. 6 times 12 gave us a perimeter of 72 centimeters. I want you to pause it and try to solve for the area. I'm going to go ahead and work out how to solve the area in my notes right now. So pause it. Once you've completed yours, go back and check with mine. So this has 6 sides, so it's a hexagon. And we have 12 times 10 divided by 2 times 6. 12 times 10 would give me 120 divided by 2 times 6. 60. 120 divided by 2 gives me 60 times 6 would be 6 times 6 is 36. Slap on the 0. So 360 square centimeters would be my answer for this hexagon. Okay, we've got an octagon now. So octa means it has 8 sides. To find the perimeter, if each of the 8 sides is 4 inches, figure out how you can calculate the perimeter. Pause and calculate the perimeter for this octagon now. Okay, in order to calculate the perimeter of this octagon, we said each side is 4. There are 8 sides total. 4 times 8 gives us 32 inches. How many triangles will the octagon be made of? This question will help us think for the area. So we've got one triangle here. It has 8 sides, so it's going to be 8 of them. What is the perimeter? We already did the perimeter. What is the area? So to calculate the area, I want you to try independently. Pause it now. When you're ready, resume. To calculate the area, I'm going to take my base of 4 times my height of 5. I'm going to divide that by 2 because that will give me the area of one triangle, essentially this one triangle here. There are 8 total triangles, so I'm going to multiply by 8 to get my answer. So showing my work, I get 20 divided by 2 times 8. 20 divided by 2 is 10 times 8 would give me an area of 80 square inches. So that is how we break down or decompose regular polygons to calculate their perimeter and area. Bring any questions, comments, concerns, ideas, methods to class with you in a little bit, and I will see you then.